Hi, guys. I wanted to go ahead and kind of go through the last couple of lessons with you all in one, because I really don't know what's going to happen with all these snow days and these delays and all these other things. So I thought it might be easier. I'm just going to kind of step you through this and then we will go over it in class next time. But these are very similar. It's going to be triangle proofs and triangle congruence proofs. And it's very similar to the other proofs we did earlier in the year, except that now we are looking at how to prove two triangles congruent. So start by finding this sheet in your packet, Triangles, Postulates, and Theorems. You don't have to pull it up right now, but just make sure you know where it is. Remember that before break, we talked about the SSS, SAS, ASA, and AAS postulates for proving two triangles congruent. And basically what we said is, if three sides of one triangle are congruent to three sides of another triangle, then we can say the two triangles are congruent, and the reason would be SSS, okay? So if we see something like this and something like this, then we have the right to say the triangles are congruent by SSS. SAS says if two sides and their included angles of one triangle are congruent to two sides and the included angle of another triangle, then we have the right to say the triangles are congruent by SAS. So you can see this diagram and this diagram show side, angle, side. So we could say the triangles are congruent would be our statement, and the reason would be SAS. ASA says if we can show in two triangles that two of their angles and the included sides in between those angles are congruent, like we see in these two diagrams, then we have the right to make a statement and a proof that the two triangles are congruent, and the reason is ASA. And AAS says that if we can show that two angles in two different triangles are congruent and a side outside those two angles are congruent, similar to these two diagrams, then we have the right to make a statement and a proof that the two triangles are congruent by AAS. Okay, I'll show you what that looks like in a second, but it's actually pretty simple. The other thing that we did not talk about is the isosceles triangle theorem. And what that says is if you're told that a triangle is isosceles, then the two sides that form the vertex angle are congruent, and the angles opposite those sides are also congruent. And you have the right to state those things because of the isosceles triangle theorem. So for example, let's say you were told that, this top part right here, triangle VQT is isosceles with a vertex angle at angle Q. Okay. Remember that if that's the vertex angle, then that's the angle that connects the two congruent sides. With that statement right there at the top, you would then have the right to say, here would be your statement, segment VQ is congruent to segment QT, and you could also make this statement, angle V is congruent to angle T, and your reason would be the isosceles triangle theorem. Okay, you remember these theorems from other lessons that we've done in the past. The midpoint theorem says if you're told that B is the midpoint of AC, then you have the right to make the statement that segment AB is congruent to segment BC by the midpoint theorem. Bisector theorem, if you're told that a segment bisects a side, then we know that cuts the side into two congruent pieces. If you're told that a segment bisects an angle, then we know it cuts the angle into two congruent pieces. So if you're given a statement like this, segment DE bisects segment AC, then you have the right to say that that means segment AB is congruent to segment BC by the bisector theorem. Or if it's an angle, if you're told that segment VK bisects angle V, then you have the right to say that angle WVK is congruent to angle UVK by the bisector theorem. Vertical angles theorem, as long as you have stated that two angles are vertical angles, and remember from the last unit that the reason for that is the definition of vertical angles. So for example, in this diagram, if I saw this picture, I would say that angle ABE and angle CBD are vertical angles. That's the statement. The reason is definition of vertical angles. And then once I've identified them as vertical angles, you have the right to say that angle ABE is congruent to angle CBD by the vertical angles theorem. So again, once you've said they're vertical angles, then by the vertical angles theorem, you're allowed to say they're congruent. And the reflexive property actually shows up a lot with triangles. It says that if a side is shared by two different triangles, you may state, and you have to actually state, that that side is congruent to itself. You're stating that to say, well, that side's actually in two different triangles. So you're saying, okay, well, RG is congruent to itself, RG, by the reflexive property. And then you can use that to come back up here to prove something like SSS or SAS or ASA or AAS or whatever it is. Okay, so that's something that you need to know, and that's important. So make sure you can do that. We're going to use those properties to do things like these proofs right here. So this is in your packets, proofs, congruent triangles, number 1. This is a clean sheet here, numbers 1, 2, and 3. After it are all of the answers to it. And the reason for that is because I wanted to kind of step you through proofs numbers 1, 2, and 3 and give you the answers so that you could also see them. And then that way you could try them on your own again without me. And then the same with 4, 5, and 6. I wanted you to try those and check your answers and then to go back, okay? But I'm going to start off, I'm going to do numbers 1, 2, and 3 with you. I'm going to just take the answer key right here and I'm going to step you through it, kind of tell you why I made the decisions I made. Then I'm going to ask you to not look at the answers and just see if you can do them on your own again. Then I'm not going to do 4, 5, and 6 with you. I'm going to have you try 4, 5, and 6, and then I'm going to have you check them, okay? So let's just take a look at this real quickly. Okay, from congruent triangles number 1, we are given that J is the midpoint of segment FH, and J is the midpoint of segment GI. And with just those two pieces of information, we are trying to prove that triangle FJI, so this triangle right here, is congruent to triangle HJG, this triangle right here. So we're not interested in the top and bottom triangles at all, just the two triangles on the left and right. Okay, just like last unit, your first statement is always to restate the given. So we have J is the midpoint of FH and J is the midpoint of GI given. Now remember what I told you last unit, take whatever word is given to you in the given, in this case, midpoint, and explain what that word means mathematically. So we know that if J is the midpoint of FH, then that means that segment FJ is congruent to segment JH. We also know that J is the midpoint of GI, so that means segment IJ is congruent to segment JG. Okay. And why are we allowed to say that right there? Because of the midpoint theorem. It's called the midpoint theorem because the word midpoint was used in the given. Okay, now take a look at the two triangles right now. In triangle FJI, you have two sides labeled, and in triangle HJG, you have two sides labeled. So think about our different theorems that we can use. We can use side, 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 angle, side, angle, or angle, angle, side. All of those require 3 pieces in each triangle to be marked congruent to 3 pieces in another triangle. So we have to have a third piece, and we've used everything that's already in the given up here. So take a look at the diagram and see if there's anything that you can mark that you don't need information in the given from. It's almost always either that they share a side or they have vertical angles or somehow it's like a right angle on one side, so it has to be a right angle on the other side or something like that. And you can see in this diagram that this angle right here at J, on both sides of J, they're vertical angles, but they've not been yet defined as vertical angles. So the first thing you need to do is you need to name them as vertical angles. So look at what I did on statement 3. I said angle FJI and angle HJG are vertical angles. And the reason is that's the definition of vertical angles, that they are across from each other from intersecting lines. Now that I've named them vertical angles in statement 4, I'm allowed to say, guess what? Those angles are congruent. Angles FJI is congruent to angle HJG. Why? Because of the vertical angles there. And then now I have a side, an included angle, and another side in both triangles. So I now have enough information to prove what I was originally setting out to prove, that triangle FJI is congruent to triangle HJG by side, angle, side. So reason is SAS. Okay? Hopefully that makes sense and you're good and you've got that. Okay, I'll just kind of erase those so that if you want to see it clearly, you can, and you don't have to worry about all this mess. Okay, all right, let's take a look at number 2. Number 2 says triangle KWD is an isosceles triangle with a vertex angle at W, and R is the midpoint of segment KD. Prove that this triangle on the left, triangle KWR, is congruent to the triangle on the right, triangle DWR. Okay, so start with the given, and then let's take the information that's in the given and work from it. KWD is an isosceles triangle. That means that 2 of its sides are equal and 2 of its angles are equal. Now, we're told that it has a vertex angle at W. Remember, vertex angle means the angle that connects the 2 congruent sides, or the angle in between the 2 congruent sides. So then we then have the right to say, because that information is given to us, that side KW is congruent to side WD or DW, and also that angle K is congruent to angle D. And the reason for that is the isosceles triangle theorem. We were told it was an isosceles triangle. We were told where the vertex angle is. So by the isosceles triangle theorem, we're then able to say, yes, those pieces have to be congruent to each other. Okay. We also know that R is the midpoint of segment KD. If R is the midpoint, then that means that these 2 pieces are congruent to each other. So we have the right to say segment KR is congruent to segment RD by the midpoint theorem. Now, looking at each triangle, you can see that they each have a side, an angle, and a side marked. Side, angle, side. So we now have enough information to prove the statement triangle KWR is congruent to triangle DWR by SAS. Now, I want to point something out here to you for just a second. Every year, I've had people ask, why do we have to mess with the midpoint? Couldn't we say RW is congruent to itself by reflexive? Yes, we could. It's not wrong to say that. But you cannot use that to prove the triangle's congruent because it's ASS. Okay? It's an angle, a side, and a side. And ASS is not a theorem you can use to prove triangles congruent. So you can mark it by the reflexive property that RW is congruent to itself, but it doesn't help you to prove the triangles are congruent. Okay? All right. So let's try one more here. And then I'd like you to try these 3 again on your own and then to go back and try the next 3, 4, 5, and 6. Okay, third proof. We're told angle K is congruent to angle G and segment DT bisects angle KTG. With just that information, prove that triangle DKT on top is congruent to triangle DGT on bottom. Okay. Start with given. Angle K is congruent to angle G is just a freebie, mark them. But the word bisects, you need to give some information about. Since you're told that segment DT bisects angle KTG, then you now have the right to say angle KTD is congruent to angle GTD by, what word used, bisect? Bisector theorem. Okay. Now, they each have 2 angles. We need a third piece, since you always need 3 pieces to prove triangles congruent. You can see that they share a side DT, so you need to state that DT is congruent to itself because it's in both triangles by the reflexive property. And now you have enough information to prove the triangle is congruent by angle, angle, side in each triangle. Okay. Please go back, try these 3 again, and then try 4, 5, and 6 and check those.